Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. Today, I'm thrilled to be joined by Peter Wang, the Chief AI and Innovation Officer and co-founder of Anaconda. Peter has been instrumental in shaping the Python data science ecosystem. In this episode, we'll explore the role of AI coding assistants, tools like Copilot and Cursor that are changing how developers and data scientists write code. We'll discuss their capabilities, the widespread industry adoption of these tools, and what they mean for the future of programming. Will AI coding assistants replace developers? Or are we looking at a paradigm shift that allows programmers to operate at a higher level of abstraction? We'll even discuss the possibility of AI native languages and what it might mean for the next generation of software development. Peter Wang is the Chief AI and Innovation Officer and co-founder of Anaconda. Peter leads Anaconda's AI incubator, which focuses on advancing core Python technologies and developing new frontiers in open source AI and machine learning, especially in the areas of edge computing, data privacy, and decentralized computing. Prior to founding Anaconda, Peter spent 15 years in software design and development across a broad range of areas, including 3D graphics, geophysics, large data simulation and visualization, financial risk modeling, and medical imaging. As a creator of the PyData community and conferences, he devotes time and energy to growing the Python data science community and advocating for increasing data literacy around the world. Peter holds a BA in physics from Cornell University. Peter, thanks so much for joining us. I'm so excited to have you here.
Well, thank you for having me. I'm excited to be here.
So we're going to chat today about how AI is affecting software development. And I want to kick off with the topic first of AI coding assistants.
Okay.
So that's tools like, GitHub Copilot, and some of the newer, I think, really interesting approaches like Cursor, which we'll talk about in a second. But let's define coding assistants first for everybody who may not be familiar with them. So these are AI agents or systems that are able to perform a bunch of tasks that were traditionally performed by developers, by programmers. You can think about it almost like autocomplete on steroids, right? But it goes beyond that. It can do code refactoring. It can fix bugs. Some of the newer systems can even take what are called sort of next action. So maybe implement a function and then understand how that function's creation or changes or refactoring might ripple out and need to have changes in other areas within the project, other files that are affected. So my first question for you is, what was your reaction the first time you saw Copilot demo? I remember mine. I was blown away. I wasn't sure how real it was, whether it was sort of a canned demo, but immediately I was convinced that this was going to be impactful.
Well, for me, the Copilot demo itself was not as surprising for me because I had been using ChatGPT for doing this kind of thing prior to the Copilot kind of integration and that particular feature, if you want to call it a product. So when ChatGPT first came out in November, almost 2 years ago, and I started putting code into it and asking it to explain code. That for me was the jaw drop moment. So I had a jaw drop moment, but it wasn't with Copilot. It was just with the original GPT-3, ChatGPT release. I took a random, not very well commented utility little Python script I had for some data munging, very specific. It was like munging some like data files for a particular project. They were in a particular directory. And the code was doing some very, I would say, fairly obscure things. I took the code wholesale, dropped it into the GPT prompt, and I said, the ChatGPT prompt, and I said, explain what this code does. And it did. It wrote documentation for this code very well. And for me, the amazing thing wasn't like going line by line saying, well, this increments the loop counter. This thing, opens a file in this directory. I mean, that'd still be impressive, but not that impressive.
A little mundane, yeah.
It was able to actually understand the structure of the code. And in fact, the way that, you're a data guy, so you'll know, like there were these directories that had data in them, but there are 2 or 3 directories that were organized differently. And so in my code, I had to basically treat those different years, the data differently. The ChatGPT explanation of my code was able to generalize that overall the code was doing this, but for these years, it was doing a different kind of processing on them. Like I was stunned that it was able to see the pattern there around that. And I at that point I knew like this is a game changer. Absolutely, it's gonna be.
Yeah. I saw a demo, and I don't remember where I saw this, but it was a couple of years before ChatGPT, and it was an OpenAI demo of this, doing essentially code generation from comments and then code completion. And at Kung Fu AI, we were talking about it, and I would say about half of us didn't believe it. About half of the people said, no way, BS. And then I think the other half of us, and I would put me in the other half, were skeptical but mind blown. And I think my mind almost immediately went to the realization that even if this is a little bit of a canned demo, we're on the right path, and this is going to be impactful. So I want to just kind of jump in with a couple of stats to tee up the rest of this conversation. So I went and looked. Now I will point this out. Take this with a grain of salt because this is a GitHub survey. And GitHub does make one of the best AI coding assistant tools out there, Copilot. But I think it's still pretty interesting. They said 97% of the developers that they surveyed had tried AI coding assistants at least once at work, and that the U.S. led with 88% of companies having at least some support for AI use, while the lowest percentage of the 4 continents was Germany at 59%. And that's pretty amazing to me to see, 90% of a population, of a really diverse population, try something this quickly. Now, I know a lot of developers who don't like it. And I know a lot of developers that really, really like it. Where are you? Like, how frequently do you use it on a day-to-day basis, monthly basis?
So day-to-day, month-to-month, I'm not coding as much as I used to.
Right.
But when I do code, I do find myself using not so much Copilot, but I do use ChatGPT to explain certain things to me. Now, most recently, and this is not for work, but most recently, some of the coding stuff I've been doing has been working on microcontroller programming with my son. He's 14. He's just started high school, and he really wanted to learn Raspberry Pi programming. He wanted to learn C. And so we were, figuring out how to drive GPIO pins and literally set high and low voltage values in I2C ports and things like that. And there was just a particular, how to get this particular chip talking to that chip thing. And the examples on the websites were all in Python, not in C. And so we were trying to read through a bunch of header files in C++. And I was like, you know what? This is just a waste of our time. I'm going to paste a bunch of this stuff into ChatGPT, and not even Copilot, but just ChatGPT, and ask it to write a skeleton of what it would do, what the right thing to do would be to set these port values. And boom, one shot. It was able to, just in that first prompt, I pasted some example. This one I'm trying to get to work, but it doesn't work. Here's the thing, and like, what is this? And it dumps it. And I'm like, wow. And here's the really amazing thing. And I said, well, but why would you set these values this way? Can you tell me, or explain why these values on these particular pins are set to this value? And it goes and it references the data sheet for that chip. And it says on page 232 of the data sheet, you have to set these register values first before you then clock in these register values. Because it just, of course, knows the data sheet for this random chip.
Right.
And so I think that is an important thing. I want to bring that into the conversation, because when we talk about the impact of these tools for coding, we have to, I think, be a little bit humble and think about and be a bit more introspective about what it is we actually do as developers. How much of it is recall? How much of it is experience? How much of it is art? How much of it is creativity and design, right? And when you look at how these kinds of tools can be used, these LLM tools can be used for each of these things, you start realizing, it can actually help each of these, but in different ways. And so there's no way I could have spent my time going through that data sheet,
right.
That PDF, this gigantic PDF, half it's in Chinese, like no way, right? And so this is the kind of thing which I think is really, really quite stunning. But of course, I did know how to write the prompt. I did know what was missing in the code. I had some sense of what was not quite working. So that certainly pushed it to a very quick resolution of an answer. Okay,
so that's really interesting, because there's more and more evidence, and I feel like I've seen this myself in a really, really strong way, which is that AI coding assistance, or AI assistance almost in any way, is almost maximally helpful to people who know what they're doing, who have more experience with it. They know how to use it. They know how to direct it, how to understand if it's made a mistake, right? Where like a junior programmer may not even know what direction to go in if they prompted the AI assistant and they got back something that was maybe on the surface look correct, they wouldn't have the experience of the intuition to know that actually you're going down a dead end. So I completely agree that the idea that knowing how to prompt it is going to be sort of a big part of, I think, the near term. I want to talk about the long term a little bit later, but in the near term, it kind of gets this idea that there'll probably be increased demand for programmers that are good at interacting with AI assistants because it's going to make you just more effective.
Yeah, I think it's a tool that developers should almost certainly be learning how to use, because the complexity of modern programming, it's way worse than when I got started. When I got started, you learned the language, you read the programming manual, you maybe learned a couple of libraries that you would use, and you'd write the code, you compile the code, you put it on a floppy, give it to somebody else.
Yeah, the ecosystem was more contained.
Yeah, well, there was such thing as an operating system. Now we don't have these things. You have a massive global distributed computer, which you deploy some code into, and hopefully the APIs that it hits, all 50,000 of them, are all still up when you run the code the next time. Right. That is not really a particularly sane environment. The fact that anything works at all is kind of amazing. But going into that, you think about all the kinds of technologies and tools that have been created as Band-Aids or as bridges into these things that people have to learn. Well, you can't be an expert in all of these things, and so if you are able to use the AI effectively and you kind of know what you want to have happen, then you're able to drive into these areas where you're weak and have that catch up. So sort of almost, I'm not really disagreeing with your point that the people who are more expert can go faster and harder, but I think that also for anyone, this is a way to fill in the void and the gaps of the areas you don't know as well. Maybe you're not an expert at DevOps. Right. Maybe you don't know a lot about computational security. You could ask the coding assistant to write what would be a good, way to do this kind of thing. You would then double check that against some other stuff. But man, that's way better than having to read a whole pile of, books on this stuff.
Oh, I totally agree. And I think for junior developers, they can get benefits maybe in a different way. Some of what you already said, which is you're trying to learn a new language, right? Mm-hmm. Maybe you know Python, but you don't know C, mm-hmm. and you're trying to figure out how to translate some code that you wrote or some ideas that you want to implement in a different language. It's a game changer there. I've used it a few times for working in more obscure languages, especially like sort of functional languages where I have a little bit less experience with. What do you think about the idea? I think this is maybe the big question within software development right now. And I'm actually surprisingly frequently, especially by younger developers, is will AI replace programmers? Like, is this now sort of a career path that people should avoid? What are your thoughts there?
I think that a lot of what programmers spend their time doing today will probably not need their time in the future. But how does that change the ecosystem and what people should be doing? And I think it's worth thinking about maybe a couple of different things. Number one, there was a time before there was programmers as an industry, and it was not that long ago. And the world did the world. I mean, the world was a functioning world, right? Right. And even a world with computers, there were not that many programmers, and it was kind of a niche thing that you would do, and it became an industry and became a job track once we had PCs and internet apps, right, and everything, software eating the world and all these kinds of concepts. So it's not written in stone anywhere that a particular job is always going to be around. It may morph and change. And I think this gets to then the question of how does AI change data science? What does the future of machine learning and data science and all these things look like?
Right.
So there's that piece. And the other thing is to think about the world. And I'm going to assume you have mostly a Western developed world kind of audience for this podcast. But those of us who travel and go to many parts of the world, there are a lot of places in the world that don't have a lot of computing technologies at all that could absolutely benefit from having some more technology, not to make them all addicted to smartphones, but just to help them in their life and accelerating industrialization, improving access to medical care, disaster relief and recovery, rooting out corruption and inefficiencies in government. All these kinds of things are really great uses of technology that we take for granted because we live in a world that has all these things for the most part here in the West. But when you go to other places, even in fairly industrialized countries, it's deeply uneven, the distribution of this kind of capability. So much of the world still runs on pen and paper, actually, right? I was just in South Korea. And there was some stuff where I was like shocked that they were like doing pen and paper stuff. And so there's just like, I think maybe an underappreciation of how much of the world could still benefit from how much basic technology. So I think, for me, if I then go that particular line of reasoning, go one extra step, I would say, well, what is good? What does good look like? Good looks like some sort of utopian ideal. Everyone has access to medical care, food, shelter. Every child has amazing opportunities and access to education and all these kinds of things. We are so far from achieving that. And there's so many people who in their hearts want to see that world come about that we will keep working until we get to that point. And there's a lot of, frankly, code that's going to get written between here and there.
Right.
There's a lot of things that get fixed, a lot of old code that has to get updated, all these kinds of things. And it's not going to be a one prompt GPT one-shot solution to any of that stuff because there are real significant human decisions and trade-offs to be made in that process.
Yeah, I think that's a really important point at the end about the human decisions. And I think that's the reason that I think AI coding systems will play an increasing role, but I think certainly in the short term, and by the short term, I mean, the next 10, 20 years, it doesn't feel to me like data scientists or machine learning engineers or software developers are going to be completely displaced. And my thought there is that it's because software is more than just writing code, right? You're building systems that interact with people, that interact with other systems. There's so much more complexity than just executing an idea. You could also make the argument that the code creation part of it is the part that is sort of the least complex, because a lot of the time you're trying to figure out what to even build, right? Mm-hmm. What capabilities do you need? What features do you need? What directions should you go in?
Yeah, and I want to draw a distinction there between the data science, machine learning side, the data-driven part, and then the code that plugs a value into a function, wires an API to some endpoint to another endpoint. Those are two, I in my mind, I see them as two kind of different classes of things. And the data science and the machine learning parts, all of the stuff that funnel into predictive analytics, again, we're just so far along the PC revolution and the internet sort of appification of everything, smartphones, consumer internet. We forget that the beginning of computing was for prediction. It was all about cybernetic systems, right? So I think we're going to quickly snap back into there. I think a lot of people who have data, people who have sensor systems, people who have embedded sensors generating data streams, they're going to be more and more leaning into this cybernetic industry. And so the business of prediction and then action on that prediction as quickly as possible. And the other side, you've got they call it just code. And that coding is more bespoke than it should be. There's this wonderful story. I don't know if you ever read this, but do you know what genetic algorithms, genetic algorithms where you try to have the computer evolve its own solution to some problem?
Absolutely.
So you map out a domain and it carves out a solution. Right. And so this is decades ago. Someone used a genetic algorithm to create like a circuit board to achieve some result. And the circuit board the computer designed was crazy. There were traces that went nowhere, but if you removed them, it wouldn't work. Why? Because the trace that went nowhere created some capacitive coupling to some other thing over there on the chip. I mean, it just worked in a way that if you were an electrical engineer, you designed that board, you would get fired on the spot, right? Because there's no way you can manufacture that scale, and there's no way you can make any modifications to it, so on and so forth. But the point is that chip or that board does work.
Right.
So when you look at when you look at computers and microchips and boards today, they have a regular layout. There's these nice traces and vias that go at various nice little angles. There's all sorts of stuff. The chips have a particular fixed size to them. All the resistors and capacitors, everything is sort of on this regular grid. It didn't have to be that way, but we make it that way. We standardize on that because that makes it much easier for people to design and then manufacture, test, and then scale these kinds of things. I think we're going to see the bespoke programming that so many people get paid for today reduced to a set of much simpler standards, which then the computer can reliably go and emit code for. And that's the next gen AI native programming environment that doesn't exist today.
Oh, fascinating. Okay, I want to dig into that a little bit more. So before that, on the genetic algorithm approach, I love that metaphor because the idea of using natural, simulated natural selection, right? Artificial natural selection to evolve, essentially, whether it's programs or whether it's chipboards or anything like that. And in fact, I'm pretty sure that Google just released, if I remember right, in the last couple of weeks, I think it's called Alpha Chip, and it's this new, AI-based, machine learning-based system for semiconductor chip design. And it's very much in that vein. But can you explain a little bit more how the genetic algorithm part plays into this more standardization on the coding side, and give some examples of the more standardized I don't want to call them templates, but approaches that you mentioned a second ago, because I think that's a really interesting area to dig into.
Yeah, I think, for me, the genetic algorithm bit of this was just to explain that there are many ways one could design a board, and that genetic algorithm did something crazy that no human would ever do. And the industry has moved away from anything like that to these standardized things, because that's just way better from a process perspective. And I think the software development industry, because it has driven so much margins for so long, it can afford a tremendous amount of bloat. So when you think about what most of the programs actually have to do, when you think about it's accessing a database, it's doing some munging, there's some data processing over here, there's some models over here that's got to go and hit some API endpoints to get some values here, and then it presents some user interface. There's some constraints and designs around the user interface, but at the end of the day, what we do for a lot of in-house programming at big companies, or even when you're building apps and stuff like that, a lot of it is just programmers fighting frozen accidents and a pile of complexity that didn't need to be there, right? And instead, if you could go from higher level expression with some constraints and almost use the AI emission as a compiler process that then hits a much more standardized low level set of components, you might end up with a much more efficient process than the current method of hiring a team of software engineers and then paying a bunch of money to go and beat their heads into some whatever newfangled JavaScript framework. Why do that?
I love that.
Right.
I love that.
So I think there's some pipe dream there maybe of an AI native language, which no one's created yet. But I've, when I'm trying to go to sleep, I think about that enough. What is the future of the first truly hybrid human AI programming environment look like?
Oh, that is fascinating. Okay, I want to touch on a couple of things that you mentioned. First off, I absolutely love your point that margins in software are so strong that they kind of allow for a lot of inefficiencies, and I think that's the reason we see 12 new JavaScript frameworks a year, and everybody's porting from, framework to framework to framework just because it's a new hotness. Or maybe the reason we see a lot of, user interfaces getting tweaked year to year that are sort of functionally equivalent, but they're just almost change for change's sake, right? So do you have any more thoughts on or can you maybe flesh out a little bit more? I love this concept of this deeper AI based approach for development. Is it more just a nugget of an idea, or do you have?
It's more of a nugget of idea, but there's a bit of muted rage at how incredibly stupid and inefficient the software industry is, and so I don't want to be. I already feel old enough nowadays. I don't want to be the old man, sort of screams at cloud kind of thing. Yeah. But I do read, programming forums, and you see some discourse on social media here and there. And so many young people who I have a lot of empathy for them, right? Trying to get into, they love programming. They have a passion for making computers do interesting things. And they immediately hit a wall of molasses of just cruft. I mean, just cruft. And so when I was teaching my son how to program, I try to keep it as simple as possible. Started with just Python, the command line. Actually, we used IPython, the command line. But then we moved to doing basic HTML. And here's a button, an HTML button. And here's how you can change the design a little bit. And here's this other thing. Here's this other thing. And then building up from there to show that you can make functional things simply. Right. And I think, I'm very lucky that he has the aptitude to sort of take that kind of pedagogy. But at the same time, I think there's something that people have forgotten how simple it can be. And so I think what happens next any kind of disruption is a worse is better kind of thing. So it's going to be some worse is better kind of thing. Minecraft is a perfect example of this. You got studios spending hundreds of millions of dollars with like professional Hollywood actors and voices and CGI and everything. And then out comes this like block laying game that everyone just loves, right? So I think we're going to have maybe, hopefully, a change in what human computer interfaces look like, where people just want to access their data. They want to have robust access to their data, that the AI can use these agents and use these tools to access these data points. And so you eventually have something like a new kind of operating system that is AI native. And then the programming environment for that operating system allows the LLM to just create you a UI very quickly that looks like a spreadsheet, looks like a calculator, looks like this, looks like that. This end user programming concept, that is kind of the formal term, end user programming, that was a huge thing in the 80s and 90s, and then it just disappeared.
Yes.
Like VBA, like you had FileMaker, you had VBA, Visual Fox Pro, you had these kinds of things. They all just kind of went away as the software industry became this huge thing that had the margins that could support a lot of hungry mouths, right?
Yeah. I even remember the, during the .com boom, there were sort of, drag and drop website building tools.
Yep,
and
absolutely.
there was very much, there was very much the thought that this might just be all you need, right?
Yeah.
It didn't turn out that way. Are there any downsides that you see or think about when you think about, AI coding assistance? Like some people talk about, could we enter a realm where we have AI building systems and then we don't even understand what was built, and we are now completely dependent upon AI, and they view that potentially as a really negative thing, something like that?
We have that now, but they're humans. Like, we have systems that are too complex that no one understands.
I totally agree.
You understand why you ask a human why this broke, and they don't know because it's a library they didn't write. They can't build it. They installed it somewhere. Building that library, no one knows how to build except very few people on Earth. It's just, that's, I'd say it's more of the same. I do appreciate, that may be a bit of a glib response, but I do appreciate people are concerned about that, right? That's a good thing, to be worried about losing our agency and losing our ability to understand what's happening. So we should be worried about that. But I think at the same time, you can use these same AI tools to build transparency tools, to build explainers, to build debugging tools. It's not like I think we would do that alongside building the systems themselves.
Right. I actually think you nailed it at the end there, because I think there are too many systems right now, like you said, where no one person understands all of it. And, there's some famous quote about, the space shuttle where there was, of course, no one engineer who knew or understood all of it, right? It takes a much, much larger team of engineers. We could get to a point, and this goes back to your comment earlier about, the C challenge you ran into, which is we could get to a point where you do have AI systems that understand every component and could act as a guide, could act as a reference and help you prevent you from going off the rails. And that's something that has never been possible before. There's never been somebody that you could go to that understood every aspect of a really complex system.
Yeah. And we're turning, it's not only the fact that you have this very large database query system, is that it is a natural language and sort of semantically, it's a semantic processing system on the input, right? And it's accessible to everyone. This is a really game changer for everyone. So to your point about, like you just said, we could partition off the different kinds of use cases. So if you have an LLM specifically designed for queries and lookups, not quite like RAG kind of things, but just the point of this is to give you an interactive natural language interface to this universe of documentation. And then the point of this thing is to just do design. And you have to give it some of this information. It'll do the design part. And this other part then does some of the implementation. Right. And this other part does the testing. We can build modular systems like this and have them kind of firewalled off from each other. There's no reason we couldn't do it that way. Yep. And that would give us a system of checks and balances, right? Right. That at some point you emit between the lookup and whatever retrieval process to the design process. You have it emit something which gives you, here is what we passed off to the design thing. You can validate that these things actually do match up to what's in the source documentation. That's the sort of thing you could do. Right.
Lex Friedman recently interviewed the team from Cursor, which is this sort of new AI coding assistant tool. And it's really interesting. And they mentioned in the interview that they have multiple custom models, kind of along with what you're talking about. Some are responsible for code generation and diffing. Some are responsible for sort of validation, different aspects. I believe they even mentioned that there's sort of this next action concept. So if you take some step, you make some code change, you introduce some diff, there would be some natural next steps that you would typically take that a programmer would typically take. And it can even predict those and go and make those flow down the line. So that kind of makes me think like, it's almost like the bar for development is being lowered in some way, right? Where, people with less experience or maybe even no experience can get started. And we talked about this before we started rolling, which is one of my colleagues at Kung Fu AI, Ryan E. Henning, brought up this really interesting point, which is there's something called Jevons paradox, which is as something becomes less expensive, sometimes the demand for it can actually go up and exceed its capacity as it becomes less expensive. So, what are your thoughts that as the ability to leverage software, the bar to entry decreases, that the demand for software and developers and data scientists and machine learning engineers actually goes up and not down?
Well, I think the direct application of Jevons paradox to this would be that as the effort to create software is decreased, that it leads to I guess it's an efficiency argument. The reason it's a paradox, right, is that you think that as it gets sort of cheaper and cheaper, the overall volume would get smaller, but actually no, it gets like just there's an infinite amount of demand. I mean, that's kind of the irony of it, is that where the paradox comes in is that there's an infinite amount of demand for it. The demand isn't necessarily to go and employ software developers. The demand is for more software. So that's a little wrinkle in that application of Jevons paradox, right? If we just look at this room right now, and I take a little Raspberry Pi, sorry to keep coming back to microcontrollers, but it's sort of,
that's great.
If I put a Raspberry Pi on here and I have one of those like colored light bulbs that are Wi-Fi enabled that I get from the Home Depot or something, I plug it in. And I want to just have a thing where there's a camera hooked up to the Raspberry Pi, and as we speak, it strobes the light or something. Now, if you were to have a normal human being trying to do this, it would be years for them to figure out how to do any of this stuff, right? But with AI, actually, assuming you had kind of the right bits plugged in, it would be able to configure the software to do this no problem. Like it would be like a matter of minutes for it to make this kind of code work. And so if you take that then to the next level where things do all become API-able, that the everything has APIs to it that the AI can then script, then your entire house, your corporate business environment, computing environment, everything is now end user programmable and scriptable with natural language. So would you call that software? I mean, yes. Does it matter that the AI wrote some software to make this data system talk to that data system, produce this spreadsheet that then emails to these people? I mean, as long as that's getting done, like I'll just have it do that. I think that's why people are moving to this frame of calling these agents, and that they do feel like you have an infinite army of electronically powered smart undergrads that can sort of just do things for you, or smart interns, right? And that is then the software creation becomes not even a thing you think about, right?
Yeah. It's my mind goes to the what do they call it in Star Trek? Like the holodeck. This idea that this, I think it's to my mind, the ultimate manifestation of this idea of like, I don't really care how this gets created or what the software is or what hardware needs to be manufactured. But if I could just tell you what I want and just have that appear magically in some form, I think that's, the direction of the world trying to move towards.
Right. Well, the example that comes to mind for me is if you, I love the thing. I don't know how it came across this in college, but when electricity was first starting to kind of make its way through the cities, and people had motors at home, and you would buy a motor and you would plug it into the wall, and then you have attachments, a vacuum cleaner attachment, a fan attachment, a pasta maker attachment, but you would buy a motor, and that was the thing. And then you plug things into it. And then now like look around this, like the studio, what things have motors in them? I don't even know, but like, does it matter? Not really.
Right.
Like, in the cameras, there's motors obviously of very specific forms for the autofocus and for the image stabilization. There's a motor inside our cell phones for the buzzing. There's a motor inside your watch for the buzzing. Do we think about that? Not really, because the motors are too cheap to think about.
Right.
And so when this kind of like the creation of just vanilla bog standard software to plug A to B is too cheap to meter, then it's just a matter of what does the person want to do, right?
Right. Peter, thank you so much for being here. This has been an amazing conversation. I feel like we moved around so many different areas that it didn't anticipate. This was just a total joy.
Well, thank you. I really enjoyed the conversation, and hopefully I haven't said anything that'll be too incriminating or embarrassing 5 years from now, that my prediction is completely off or whatever. But yeah, thank you so much for having me here.
Thank you.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.